The Great Filter. You've probably heard the term in science fiction circles. It usually refers to some barrier preventing a species from reaching a certain level of technological advancement, a barrier often posed by advanced alien civilizations. But what if the Great Filter exists not in the future, but in our past? What if the barrier we've passed is not a gate of technology, but a door of perception? What if we've already crossed the threshold into a reality we do not comprehend? And what if the key to understanding that reality lies not in future innovations, but in past encounters? Let's take a journey back to 2017, the year Oumuamua entered our solar system. It arrived without fanfare, unnoticed amid the millions of space rocks catalogued each year. It was only days later that astronomers noticed its peculiar movement, not just falling around the sun, but speeding away from it. At first, scientists believed it to be a typical comet, an icy remnant from the early days of our solar system. But Oumuamua was not your standard space rock. It didn't follow the expected trajectory. It didn't exhibit the usual volatile emissions, and it rotated strangely, tumbling erratically on its axis. And as it moved through the solar system, it revealed more mysteries. Its surface was smooth, lacking the rough texture of space rocks. Its color was dark, almost black, and its composition was bizarre, rich in nitrogen and carbon monoxide, hinting at an origin outside our solar system. Scientists were baffled, theories abounded. Some suggested it was a military satellite lost from another civilization. Others claimed it was a gigantic alien scout ship. But the truth was stranger than fiction. It was a chunk of nitrogen ice, ejected from a far-off planet, perhaps a bloated Neptune, and propelled across the galaxy by gravitational nudges and stellar winds. Oumuamua taught us something essential about interstellar space. It showed us that the silence of the void is deceptive. Even in the emptiness, there is movement. The question was, how much movement? 6 years passed. No other interstellar objects were detected. Was Oumuamua just a fluke, a random visitor from another system? Or was it a representative of a steady stream of wanderers passing through our solar system? In 2019, Boris arrived, confirming the first part of the answer. It wasn't a fluke. Here was another interstellar trespasser, this one rich in carbon monoxide and methanol, showing signs of volatility. Both Oumuamua and Boris were pieces of a puzzle, and as they fit together, they revealed a picture of intense activity in the interstellar deep. But what was missing was the perspective, the understanding of a constant flow. We needed to know how many objects like this were traversing the galaxy, how often they visited our solar system, and we needed to understand why. Enter 3I or Atlas, the latest addition to the cosmic narrative. Unlike its predecessors, 3I or Atlas was large, 10 kilometers wide, covered in reflective ice and leaving a substantial tail in its wake. It was moving fast. Too fast for any local object, too fast for a mere comet. And it was getting closer, passing Mars in February 2026 and swinging by the Sun in March. It is this proximity that gives us the opportunity to learn more than we ever have before about interstellar space. And what 3/8 is telling us is radical. It's not just an object, it's a signpost pointing not just to where it came from, but to where others might be going. As 3 Atlas races towards the Sun, it will pass within range of several powerful Earth-bound telescopes. Researchers are focusing on two things: mapping its orbit and analyzing its composition. With a precise map, we can trace its trajectory back in time, understand the forces that shaped it, and predict where it might go next. Already, scientists have estimated its age to be between 3 and 11 billion years. That puts it at the dawn of our solar system, possibly ejected from another system altogether, and as it approaches the Sun, its composition will reveal itself. By measuring its albedo and spectral reflectance, we can identify the elements on its surface. It's likely to be rich in carbon monoxide and other volatiles, offering insights into its origins and journey. And this is where the significance of 3/8 becomes clear. If it's an ancient object, if it's been traveling for billions of years, it could be carrying information that is incredibly old, older than anything we've ever seen before. And what if that information is meant for us? What if Oumuamua, Boris, and 3/8 are not just interstellar rocks, but messages from the deep? Imagine the implications. We'd be decoding signals that started long before our solar system formed, potentially communicating with civilizations that existed in the darkness before the first stars shone. The implications are staggering. We'd be connecting across the galaxy through time, but what kind of knowledge would such messages carry? Perhaps tales of worlds long gone, accounts of civilizations that rose and fell before the universe expanded so vast. Or maybe they'd be warnings, echoes of civilizations undone by their own advancements. Either way, we'd be stepping into a narrative that stretches back to the origins of galactic life. Of course, this is speculation, fueled by the mystery of interstellar space, but the possibility is intriguing. We are constantly searching for signals in the cosmic microwave background radiation, trying to find whispers from the early universe. But what if those whispers are not faint echoes, but present voices carried by interstellar travelers? As 3/8 approaches, we're preparing not just to observe an object, but to listen to an echo from the past, a tale from the deep, a message from beyond the stars. This is not just a scientific mission. It's a step into the unknown, a leap of imagination, a hope for connection. Because in the grand expanse of the universe, we are not alone. We may be talking to ourselves, but the question is, are we listening? When 3I or Atlas reaches its closest point to the Sun, it will be just 14 astronomical units away, making it visible from Earth with a naked eye, assuming it remains on its current trajectory. Unfortunately, it won't be visible from North America. The best places to view this comet will be from the southern hemisphere and eastern Asia. According to astronomers, 3I or Atlas will appear brightest around the end of January 2026 when it passes Mars. It's expected to reach a peak magnitude of about 10, which means it will be faint and difficult to spot without the aid of a telescope or binoculars. The comet will remain visible until March 2026, when it swings by the Sun and disappears back into interstellar space. In summary, here's what you need to know. The best viewing location, Southern Hemisphere and Eastern Asia. Peak brightness, approximately magnitude 10. Peak visibility, end of January 2026 during its approach to Mars. Disappearance, March 2026 after passing the Sun. Remember, while this comet won't pose a threat to Earth, it offers an invaluable opportunity to study interstellar objects up close. Make sure to stay updated with the latest observations and predictions from astronomers. Share this information with friends and family who might also be interested, and keep looking up to the sky as we uncover more secrets of the universe. Thanks for tuning in. Don't forget to share and subscribe to our channel for more updates on fascinating celestial events. Stay curious and keep exploring the wonders of space.